Okay, I know that you guys graphed before in Algebra 2, but now we're going to put it in with the radians. You guys did degrees. The shape of the graph doesn't change. Cosine will always look the same. Sine will always look the same. And when we get into some of the other trig functions, they'll always look the same unless you alter them, like by squaring them or multiplying trig functions together. But the basic cosine function always looks like this. That is cosine over 1 period. All right? And that is, again, the basic cosine function. Now, we'll put little arrows on the end because this does go on forever and ever and ever and ever and ever in both directions. It just repeats itself. It's known as a circular function. It just keeps going and keeps going and keeps going. But when we graph it only over only one period. Now, before we get into just graphing this, I want you to see where these points come from. And when I graph, I always use something called the 5-point graphing method. And those 5 points come from my theta, or my angle, being 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, these are how I get my 5 points. If I sketch a graph, because my angle that I'm putting in is theta, it can be x just as easily, but because I'm changing my input value to theta, that makes my typically x-axis become the theta axis. And then my y-axis is my output. And if I go through and find these values, what is the cosine of 0 pi? And I'm just going to do a quick sketch of the unit circle around here just really quickly to put those points in so we can grab them fairly quickly. This is 1, 0. Up here is 0, 1. Over on the far left is -1, 0. Down here on the bottom is 0, -1. And those are where I'm going to draw my values from. Remember, when we do our point, it is cosine sine. That's a C. That's supposed to be a C. Okay. Cosine sine, it goes in alphabetical order. Cosine comes first, sine comes second. So what is the cosine of 0 pi? 1. What is the cosine of pi over 2? Cosine of pi. Cosine of 3 pi over 2. And cosine of 2 pi. So I'm going to add my values. I always do 4 tick marks, I call them, on my theta axis. Those 4 tick marks represent the end of each quadrant. And those are those points that we just looked at here to grab these values. It's pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm going to look at this. This graph is going to max out at 1, and it's going to bottom out at -1. And now I just put those points all together on my graph. I can't believe I stayed with that brown color for so long. Ugh. Okay. I plot the point. That means this origin, the origin coordinate is 0 pi 0. It's still 0, 0, 0 pi 0. And so 0 pi goes to 1. Pi over 2, this is just an ordered pair. Pi over 2, 0, just graphing it like it's on a coordinate plane. Pi -1. Square root of 3 over 2, 0. Or sorry, 3 pi over 2, 0. Ooh, what was that? And then 2 pi 1. Now, if you look at it, it looks like if we graph it, it would be an absolute value or a V graph, but it's not. Remember, this is a circular function, so it's all curved. So when we graph this, we graph our nice curves. Now, I want you to remember when you graph this, because sometimes people get a little bit sloppy when they graph. 1 is the high point. Cosine will not equal anything over 1 ever. It's restricted in the unit circle. So 1 is the high point for my standard cosine. That means that it's going to flip back down. So keep in mind, like we have an upper kind of blocking here that's going to force my graph to turn back down. Likewise, we have the lower blocking here. Okay, so it's sandwiched between that maximum value of 1 and that minimum value of -1. All right? So those are where our points come from. And if you remember what cosine looks like, all you'll need to do is do your 5 points and sketch your graph, and you don't have to go through and make a table and evaluate. So cosine will always look like this. I have, like I said, a high point and a low point. And the high point and the low point help us find something called the amplitude. The amplitude is the distance that the high point and low point are from the center of the graph. The amplitude is the distance the high and low, max and min, points are from the center of the graph. I'm running out of room a little bit, okay? So the distance that it is again, if I don't do any shifting of my graph, my distance goes 1 point up from the center and 1 point down from the center, making my amplitude 1. And I always abbreviate just with AMP. I also have something called a period on the graph. And the period is how long it takes the graph to repeat itself. And if I do nothing to the angle, it is going to be, or I do nothing else to the function, it is going to be where I put my last point for cosine and sine. Now that changes a little bit for some of the other trig functions. So I abbreviate period with PER, and my period is 2 pi. When you sketch a graph, those are the things that are going to be asked of you. What is the amplitude? What is the period? And then you're going to have to be able to sketch a picture. Now again, this is just the basic cosine. We've done nothing to it. We're going to do the same thing, go through a basic sine. We're doing nothing to it. And then I'm going to show you how other things added are going to affect it. But we can still graph using our basic 5-point method. We just have to adjust some of the numbers along the way, okay? So sine. Basic sine looks like this. And actually, I should add my little arrows. And I can get my values the same way for sine. I have theta, and I have the sine of theta. And I use my still 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. And if I go back up to that circle that I had up on the top, I'm going to fold my paper down and see if I can get that on there. That same circle that we used to find the cosine, I can use it to find the sine. It's just that now I'm looking at the second coordinate. So it's going around the circle, 0, 1, 0, negative 1, 0. I just picked the sign, 0, 1, 0, negative 1, 0. Nothing fancy. And so when I sketch this graph, I'm still using those 4 tick marks. I've done nothing to the angles and nothing to the height of this graph or the amplitude of this graph. So all of these are just going to be our regular old 1 lap around the unit circle, basic. And then I can go ahead and sketch my sine graph. Starts at 0. Again, I do the 5-point method. I make my points always super big and boogery. Like a big old wad of a point going on there. No big deal. Again, I'm in these restrictive zones. This cannot go higher or lower, which means that this arrow here is going to have to come back up and flip back down, come back up and, or come down and flip back up. It's going to be sandwiched between that max height and that low height. So don't let your things go crazy all over the place. Keep them restricted in our zone, and it's going to continue forever and ever and ever and ever. Just like cosine. The amplitude is the distance from the center to the high point on the graph. And in this case, center to the high point, center to the low point, 1 unit. And the period on this is also the same. How long it takes to repeat itself. It's 2 pi. Once it starts and gets to 2 pi, it starts to do the same thing over and over and over again. That's what I mean by the period. That's what the graph looks like. It's going to repeat forever after. Okay? All right. So, basic cosine, basic sine, that's what they look like. What happens when you start messing with them? The thing is, not too much. It might stretch it taller, or stretch it out, or shift it to the left or the right, or up or down, but the basic graph looks the same. And so as long as you number your graph appropriately, your graph almost always will look identical. So on this one, I have a cosine graph. Cosine looks like this. What has changed on this cosine graph is this number in front. That means whatever value I get in the table, I'm going to multiply it by 3. So if I look at my original table, I can get that down there. I don't know if I'll be able to do this. Okay, if I look at my original table, every point that I have in here is going to be multiplied by 3. That's my basic cosine. So this will be 1 times 3. Before I start graphing, I better label my stuff. I didn't adjust my angle at all. I didn't adjust theta. Nothing's added to theta, subtracted from theta, multiplied by theta, divided by theta, nothing there. Theta is theta. That means that's going to be my still basic 1 lap around. But then that 3 in front, like I said, multiplies every point that I have by 3. So I do 1 times 3. That means I'm going to top out at 3. 0 times 3. Negative 1 times 3, so I'll bottom out at negative 3. 0 times 3, 1 times 3 again. So that front number affects my amplitude. So I'll sketch my graph. And my amplitude has changed. Now if I measure the distance from the center to the high point, or the distance from the center to the low point, it is 3 units from the center. 6 units total height, right? But that's not what I'm doing for amplitude. I'm doing from the center of the graph, and the center of the graph right now is on the theta axis. And my period, because I did not mess with theta at all, is simply still 2 pi. So the number in front changes the amplitude. The number in front of theta changes the period. So this 2 that I have here is going to change the period. That means it's going to change how long this graph is, how long it takes to repeat itself. And what this means is, because we base this all out of our unit circle, and 1 lap around the unit circle is 2 pi, this tells me, the language of this is, I can fit 2 sines in 1 lap. So this 2 says you can graph 2 sine graphs in 2 pi. That's 1 lap around the unit circle. Squeezing a lot in there. Okay, that's what that tells me. You can graph 2 sines. If it were 3, you could graph 3 sines. If it were 4, you could graph 4 sines. If it's a half, you can graph a half of a sine in 2 pi. But I only want to graph 1 period. So if I can graph 2 sine graphs, I'm just going to draw a little sketch. If I can graph 2 sine graphs in 2 pi, 1 sine graph, 2 sine graphs in 2 pi, how long will it take me to just graph 1 sine graph? Pi, half of 2 pi, right? So right here would be the middle point. So when I make my graph, because I am only interested in 1, I'm going to force it to end at pi. Does that make sense? If I can get 2 in 2 pi and I only want 1, I'm only going to graph 1, which would be half of that amount. Now the amplitude didn't change. I'm going to put 1 and -1. Remember, that's going to where my graph is going to top out, where my graph is going to bottom out. But now I need to fill in the rest of the places. So these points in here, these intervals, even though it's not, if you took a ruler, you'd be like, no, they're not exactly the same. They're supposed to be, okay? And we're not perfect, so we're trying to make them as close to the same size interval as possible, and that's what they should be. That means everything is equally spaced, and so I can break this down into quarters. And when I do it, all I do is I start with the halfway mark and I cut it in half. So what's half of pi? Just pi over 2. Then I take the halfway mark between 0 and pi over 2, because that would be the quarter way mark, And so I cut pi over 2 in half, and when you cut a fraction in half, you just double your denominator. So that says pi over 4 if it were at all legible, pi over 4. And then I just count, or some people add these two together, or you can multiply it by the quarter mark that it sits at, but I just count. This is 1 pi over 4, and they're evenly spaced, so I'm going to go to 2 pi over 4, because that would be a half pi, and next would be 3 pi over 4, so that's my next mark. And those, yes, have to be on there. And if you're like, oh, I don't know if I'll remember that, here's the general rule of thumb. This spot is 1/4. It's the quarter mark. We have 4 equally spaced spots. This spot is the quarter mark, so it's 1/4 pi. This is the half mark, so it's half pi. This is the 3/4 mark, so it's 3/4 pi. So all you do is take the period that you have, and it goes into that spot, or you take that number that you figured out and it goes into that spot. All right, once we have that, the hard stuff is done. I can go ahead and sketch my sine graph. Sine graph starts at 0, goes up, goes back down to 0, down to the negative end, and I sketch my graph, keeping it within its boundaries. And if you compare your first sine graph to this sine graph, they probably look very similar. The big difference is that we're changing these values. That's why I said earlier, the look of the graph isn't going to change. It's just going to shift its movement, and the values are going to change a little. If I were to graph these two together, if I go back up to my sine graph, and you don't need to do that, but if I were to graph these two together, this would look like half the graph. Can you see that on there? Yeah. This is y equals sine 2 theta. And that's what that piece of the graph will look like, so it'll be half. But we're not graphing them together, we're graphing just one. And so you can just label the things accordingly, and as long as your numbers are right, you're in good shape. Good? Okay. Now we're going to kind of combine stuff. And through the years, it amazes me kind of, but maybe it doesn't, I don't know. Every time some people see fractions, it's like they shut down. It's like, the brakes go on immediately and they freak out and I can't do fractions, I can't. Don't, just relax. They're okay. They're not your enemy. They are all right. This theta over 2 means 1/2 of theta. And so if I translate that, that means I can fit 1/2 of a cosine graph in 2 pi, which is 1 lap around the unit circle. I can only fit half of it in there. So if I can only fit half of it in there, how much space am I going to need to get the whole one? I'm going to need to double this and get to 4 pi. So when I make my graph, my end number is 4 pi. Cut that in half, 2 pi. Cut that in half, 1 pi. Start counting, 1 pi, 2 pi. Next up is 3 pi. This is my period. So far I've just been sort of talking through what we're doing when we're finding our period, how long it's going to take to repeat itself, etc. But we do have like a little sort of formula we can use. And if I put my general cosine or sine equation with values in front of the trig function and in front of the angle, the absolute value of A will always give me my amplitude for sine and cosine. The absolute value of the number in front will always give my amplitude for sine and cosine. And 2 pi over B will always give me my period for sine and cosine. This is for sine and cosine, and I keep saying that over and over again, for sine and for cosine, because that's not the case for all of the trig functions. This is the case for sine and for cosine. So this, again, is for sine and cosine. That will always be true. So what I could do is take this 1/2, which is in my B position, and I would do 2 pi over 1/2. Well, I don't divide by a fraction, I flip and multiply, so this becomes 2 pi times 2 over 1, or 4 pi. So that's mathematically how you can do it. If you get some funky numbers, you can just plug it into that little equation. Good? Okay. So 4 pi is what I have here. Then I have my adjusted amplitude. So my amplitude is the number in front, absolute value of the number in front. The distance will never be negative, so if the number in front is negative, which we'll come across shortly, it doesn't change, or we have to change it to positive for a distance. Okay? So now that I have everything labeled, I can go in and graph my cosine. I know what cosine looks like. I put my 5 boogery dots on here, and I sketch my graph. And I state that my period is 4 pi, and that my amplitude is 2. So far doable? Any questions? Are these graphs going to change? Nope. Again, tomorrow we'll add on a little bit of shifting left and right, up and down, but today we're not even going to do that. Everything's going to be centered on the graph. So let's do our sine. Again, I remember what sine looks like. Sine always looks like this, so my sine is going to look like that. This tells me that it is stretched out taller. So that means this graph is going to top out at 2 and bottom out at -2. This 3 here tells me that I can fit 3 sine graphs in 2 pi, but I only want 1. That's a little bit harder to visualize than a 1/2 or 2. So what I'll do is I'll go through that little thing we talked about over here, and I'll take 2 pi over B to figure out what my value is. So my period on this graph is 2 pi over 3. So if I can fit 3 into pi, then I can fit 1 in 2/3 pi. And that means that when I put my 4th tick mark here, it is 2/3 pi. Again, before, when I had some of those numbers, it was pretty easy to cut in half and cut in half and count and move. And now it gets a little bit more difficult to cut in half. But remember, to find your halfway mark, all you have to do is half of whatever the period is. Well, I double the denominator when I cut it in half, so that's 2 pi over 6, and then I reduce it, so that would be pi over 3. Which hopefully makes sense. Half of 2 pi over 3 is 1 pi over 3, right? And then half of that would be 1/4 times 2 pi over 3. Or again, I just cut that in half, meaning I double the denominator. But mathematically, you can just plug this in your calculator if you need to, or figure this out. It's going to get you the same answer. And then I count 1/6 pi, 2/6 pi, 3/6 pi, 4/6 pi. 3/6 pi is 1/2 pi, or pi over 2. And again, you can do 3/4 times 2 pi over 3. And then your whole period is that. I forgot to state my amplitude. Amplitude is the absolute value of the front number. That's 2. And now I'm going to go ahead and sketch my graph. Sine. So I make my 5 points. Whoops. Sometimes if I don't cross my circle, I just keep drawing over it until I do. We don't judge, right? So on the last two, we're getting some funkier numbers. And another thing that we're doing is we're throwing a negative in front. And the negative doesn't do too much other than it flips your graph. So if a regular cosine starts up at +1, a negative cosine is going to start down at -1. Okay, so just a little side note. If y equals cosine theta, my graph will look like this. If y equals negative cosine theta, my graph will look like this. That's all it does. Flips it over. What's the amplitude of this graph? Absolute value of the number in front, 18. So when I sketch my graph, it is going to top out at 18 and bottom out at -18. And you might be saying, hey, that looks like the same distance that you put 2 on the other graph. Yeah, except for now it's 18. And that's the key difference, right? I know that 18 is much taller. This graph is going to be much taller than 2. But we don't need to make it taller on our picture. And you don't need to like count 1, 2, 3, 4, 5. Just put that there. And then I have to figure out the period. And the period, this says I can only fit 1/5 of a cosine graph into pi. So I translate this here as 1/5 theta. That means I can only fit 1/5 of a cosine graph into pi. I want a whole cosine graph. So I have to figure out what that's going to make my end line be. I don't divide by a fraction, I flip and multiply. This is 2 pi times 5/1 or 10 pi. So my period is 10 pi. Make my tick marks, cut them in half, cut that in half, 5 pi over 2, 10 pi over 2, 15 pi over 2. I count by the same interval, or again, multiply by 1/4, multiply by 1/2, multiply by 3/4. This would be 1/4 of 10. This would be 1/2 of 10. And 3/4 of 10. You decide which method works best for you. You decide what works best for you. It's all personal. Cosine graph, but negative means I start down. I'm still within that restricted zone, so I don't want to go above or below. Oops, missed that one. Come on. And I sketch my graph. And one last problem. I want to see if you guys can put it all together. So I'm going to freeze my screen and see if you guys can get the answer to that one using everything that. When you're done, take a peek, see how you did. It's kind of ugly numbers, but remember we don't judge. We don't judge. That's one thing we don't do in here. No judging. Any questions? I see some eyebrows that are like looking like, are we okay? Anybody? Yeah.
How do you turn the